In this video, we are going to find the rank of a matrix. Before finding the rank of a matrix, we will see what is a equivalent matrix. Two matrices are said to be equivalent when for any given matrix. For example, I take matrix A is equal to 1 minus 2 2 minus 1 1 3 1 minus 1 minus 4. Now I am going to bring a matrix equivalent to the matrix A by interchanging, or we make the operation such that I change the second row of the given matrix to R2 plus R1. Now we are going to add the R2 row, second row with the first row, and I am going to change the matrix here. Matrix can be written as this A matrix is equivalent to, this symbol denotes equivalent to. I make the operation to R2 plus R1. So minus 1 plus 1 gives us 0. First row we write it as 1 minus 2 2. There is no change in the first row. I change the R2 elements here. We get 0. 1 plus of minus 2 gives us minus 1, 3 plus 2 is equal to 5, and the third row remains as it is. This is a matrix which is obtained from the A matrix, and therefore we say, for example, we take this the obtained matrix to be is equal to B. We say A is equivalent to B. How did we get this B matrix? This B matrix is got from the elementary transformation. What is this elementary transformation? Either we can make the elementary row or column operation by interchanging any two rows or columns of the matrix, or replacing a row or column of a matrix by a scalar, non-zero scalar of any other row or column by a non-zero scalar, or replacing the matrix by the sum of the row or column with a non-zero scalar multiple of any other row. So here we have made the transformation by taking the sum of R1 and R2. Now coming to this, there are two types to find the rank of the matrix, two methods to find the rank of a matrix. The first method is the minor method, and the second method is the row-echelon form. So here we see the definition for the row-echelon form of a matrix. All the zeros of E is the matrix given, occur below every non-zero row of E. And next, if the first non-zero element in any row I of E occurs in the jth column of E, then the other entries of E below the first non-zero element of the row I are all 0. The first non-zero entry in the ith row of E lies to the left of the first non-zero entry in the I plus 1th row of E. So let me give an example to make it clear here. I take a matrix A is equal to 1, 1, 2, 2. Now I am going to make this is of order 2 by 2. I am going to make the elementary row operation by taking R2 to R2 plus minus 2 times of R1. So what is the equivalent matrix we get here? 2 minus 2 into 1. So gives me, first row remains as it is. We change the second row, so we get 0 and 0 here. Now what about this matrix? Here we get the last row, the elements are all 0. This is a 0 row and this is a non-zero row. So number of non-zero rows in the given matrix is equal to 1, and therefore we write a row of A is equal to 1. This symbol denotes the row, is row, and denotes the rank of the matrix, where the rank of the matrix is 1. So we have some note here. A be the given matrix. Matrix obtained by deleting some rows or columns of the matrix is called as a submatrix, and the matrix is said to be a submatrix of itself because it is obtained by leaving 0 number of rows and 0 number of columns. Then definition, the rank of a matrix is defined as the highest order non-vanishing minor of a matrix A denoted by the symbol rank of A, and the rank of the 0 matrix is 0, and a note is given if the matrix has at least one non-zero element rank of A is greater than or equal to 1. Rank of an identity matrix of order n is n. If the rank of a matrix is R, there exists at least one minor of A of order R which does not vanish, and every minor of A of order R plus 1 vanishes. Higher order vanishes. If A is m by n matrix, rank of A is minimum of m comma n, and a square matrix of n is invertible if and only if rank of A is equal to the order of the matrix is given to be n. Let us see an example here. I take a matrix A is equal to of order 3, 2, 4, 1, 1, 0. The order of this matrix is 3 by 2. Now, we can find the rank of the matrix. The rank of the matrix will be is equal to the minimum value of 3, 2. Or the rank of the matrix is less than or equal to minimum value of 3, 2. Here the minimum value is given to be 2. So the rank of A must be less than or equal to 2, and then we find the rank by either using the minor method or the row-echelon form, which we are going to do the problems in the exercise. Moving on to the exercise problem, the first question of the exercise, let us take the given matrix to be is equal to A matrix, where A is equal to given 2, -4, -1 and 2. Find the rank of the following matrix by minor method. So minor method, we find the minor here. The determinant of the given matrix, this is of order 2 by 2. So the rank must be naturally less than or equal to, for this matrix the rank must be less than or equal to 2 here. So determinant 2 -4 -1 and 2. So this is equal to 4 minus of 1 minus 1 into -4. So we get 4 minus of 4, which is equal to 0. Rank is equal here. Determinant is equal to 0. We say the rank of the given matrix is not equal to 2. So if the rank is not equal to 2, then we go for checking whether the rank is 1. Here in the given matrix, there exists at least one non-zero element. Any number we can take, any non-zero element of the given matrix is a non-zero. For example, we get a matrix A is equal to 0, 0, 0, 0. Then here, this is a null matrix, so the rank we can say is equal to 0. Suppose A is a matrix with 1, 0, 0, 0. Here, the rank of the given matrix, here we have a 0 row, 1 non-zero row. There exists at least one non-zero element. So in this case, we can say rank is equal to 1. This is for example we have taken. Now, in this given problem, rank of A is not equal to 2. Rank, when we take the minor, consider the minor of a 2 cross 2 matrix, we get 0. Therefore, we say rank is not equal to 2. Therefore, there exists at least one non-zero element, and therefore we say the rank of the given matrix is equal to 1. Moving on to question number 2. Given A is equal to -1, 3, 4, -7, 3 and -4. The order of the given matrix is 3 by 2. It has 3 rows and 2 columns, and naturally the rank of the given matrix must be less than or equal to minimum of 3 and 2, and therefore the rank must be less than or equal to 2. I take a minor here. Deleting any row or column in the given matrix is called as a minor. So I take the minor. Minor taken according to our problem, I take the consider the 2 by 2 minor here. We are considering the minor -1, 3, 4, -7. Value of this minor is 1. -1 into -7 is 7. -12 is equal to -5, not equal to 0. So the 2 cross 2 minor is 0. Therefore, we can say rank of A. We say the rank of A is equal to 2. Suppose this is equal to 0. Suppose we get 0. Then we go on considering for the next minor and check whether the rank is equal to 2 or not. If suppose all the possible minors of the given matrix, if all the possible minors of the given matrix are 0, then we say the rank, there exists one non-zero element in the matrix and rank is 1. So here for the second question, rank is equal to 2. Moving on to the third sum. Moving on to the third question. Third question is matrix A is equal to -1, -2, -1, 0, 3, minus 6, minus 3, 1. The order of the matrix here, it has 2 rows and 3 columns. Therefore, the possible rank of the matrix is given to be less than or equal to, the rank must be less than or equal to 2. So, I consider a 2 cross 2 minor here. Consider any 2 cross 2 minor. For example, I take the 2 cross 2 minor here. 2 cross 2 minor when I take, minor is minus 2, minus 1, minus 6, minus 3. The value of the minor will be 6 minus 6 is equal to 0. Next we consider another minor. All possible minors must be taken inside the matrix. So when I take the minor, we consider the next possible minor. Consider the 2 cross 2 minor. Minor is taken as minus 1, 0, minus 3, 1, which is equal to minus 1, minus 0, which is equal to minus 1, not equal to 0. And therefore, this case we say rank of A is equal to 2. So what have we done here? One minor we have checked is equal to 0. So we go for the next possible minor. It is not equal to 0. Therefore, we say the rank of A is equal to 2. Next, moving on to question number 4. Question number 4, let us take the given matrix A is equal to 1 minus 2 3, 2 4 minus 6 and 5 1 minus 1. This is a 3 cross 3 matrix. Therefore, we have to take the rank of A must be less than or equal to 3. There is no minimum value here. Both M and N are equal here. Therefore, the rank must be less than or equal to 3. We will find out what is the rank here. Taking the determinant of A will be is equal to determinant of 1 minus 2 3 2 4 minus 6 5 1 minus 1. So expanding the determinant, this is equal to, you know, to expand the determinant by taking the plus minus plus sign. To expand the determinant along the first row. So we have 1 into the minor of 1. 1 into minor of 1 will be is equal to minus 4 plus 6. Next element will be minus 2 into, we take the minor, so that is equal to minus 2 into minus 2 plus 30 plus 3 into 2 minus 20. So we have expanded the determinant. Now we are going to find the value of the determinant. So this is equal to minus of minus 2 into, this is minus of minus 2 into, so this gives us plus here. So 2 plus 56 minus 54, which is equal to 4, not equal to 0. So expanding the determinant, we get not equal to 0. So we say the rank of A is equal to 3. Next, moving on to the 5th question. Given matrix A is equal to 0 1 2 1, 0 2 4 3, 8 1 0 2. The order of the given matrix is 3 by 4. It has 3 rows and 4 columns here. So let me consider. So the possible rank of the matrix must be less than or equal to minimum of 3, 4. So the rank must be less than or equal to 3. Consider any 3 cross 3 minor from the given matrix. I take this minor here. So let us find the determinant of consider a 3 cross 3 minor. Zero, 1, 2, 0, 2, 4, 8, 1, 0. Now we expand along the first column. So expanding along the first column, 8 into, we get 4 minus 4. 8 into 4 minus 4 is equal to 0. So when we consider this minor, we get is equal to 0. Let us consider the next minor of the given determinant. Consider a 3 cross 3 minor. We have to consider all the possible minors. I take the first column, third column and the fourth column. So this is my determinant of 0, 2, 1, 0, 4, 3, 8, 0, 2. Expand along the first column, we get 8 into 3 into 2 is 6, minus 4 into 6 minus 4 into 2 is equal to 16, which is not equal to 0. Therefore, here 1 3 cross, when we take 1 minor, it is equal to 0. Consider another 3 cross 3 minor, it is not equal to 0. So I say the rank of the given matrix is equal to 3. Next, moving on to question number 2. Find the rank of the matrix by row reduction method. The first question taken, A is equal to the matrix 1 1 1 3 2 minus 1 3 4 5 minus 1 7 11. I am going to make the elementary row operation here. First row we leave it as it is. I change the second row. See, make a note to bring to maximum number of zeros. When I multiply this first row by 2, subtract with the second row, we get this element to become 0 here. So row-echelon form is nothing but the first element is a non-zero element. For example, we can have it as 1. Then the remaining A21, the first is a first element. The first entry is a non-zero. A11 element can be taken as a entry is a non-zero row-echelon form. This is the procedure. Then A21 element must be taken to 0. A31 and A32 element must be taken to 0. This is the row-echelon form. This is the procedure. We have to transform the matrix to bring it to the row-echelon form. So in order to bring this A21 element to 0, I take R2 tends to R2 minus 2 times of R1. The first row remains as it is. So 2 minus 2 becomes 0. Minus 1 minus 2 into 1. So gives me minus 3. Next 3 into minus 2. 3 minus 2 gives me 1. And 4 minus 6 gives me minus 2. R3 tends to R3 minus 5 times of R1. So gives me 0 here. This is minus 1 minus 5 is minus 6. 7 minus 5 gives us 2. Next 11 minus 15 gives me minus 4. So I have brought A21 element, A31 element to 0. Next we have to bring this element to 0. So I make the row, again I make that elementary transformation here. Transformation taken to be R3, I am going to change to R3 minus 2R2. So the first two rows of the equivalent matrix remains the same. The last row is changed. 0 minus 0 gives me 0. This last transformation, when these two elements are 0, always we make the transformation with R3 and R2. So 0 minus 0. Minus 6 plus 6 gives me 0. Next 2 minus 2, 0. Minus 4 plus 4 gives me 0. Here, this is the, we have 1 0 row here. This is the 0 row. How many non-zero rows we have? 2 non-zero rows we have. Therefore, we say the rank of the matrix is equal to 2. The equivalent matrix can be written as, we have the first row as it is 1 2 minus 1. I am going to change the second row. R2 2, R2 minus 3 times of R1. So 3 minus 3 we get 0. Minus 1 minus 6 minus 7. 2 plus 3 which is equal to 5. Next we change R3. R3 to R3 minus R1. So I am going to make the transformation by taking R3 minus R1. So we get 1 minus 1, 0, minus 2 gives us minus 4. 3 plus 2, R3 minus R1, so 3 minus of minus 1, so 3 plus 1 gives me is equal to 4. Next we change R4, there are 4 rows, the rank of the given the order of the given matrix is 4 by 3. So R4 tends to R4 minus R1. So 1 minus 1, 0, minus 1, minus 2 gives us minus 3. Minus 3 and 1 plus 1 gives us 2. Next, this equivalent matrix our here this element A31 element is 0, A41 element is 0. Our aim is to make this element to 0. The first entry is a non-zero entry. These are the conditions to bring it to the last matrix to the row. Must be an equivalent row in row-echelon form. So 1, 2, minus 1, 0, minus 7, 5. First two rows, have it as it is. R3 tends to 7 times of R3 minus 4 times of R2. R3 minus and R3 and R2 we make the elementary transformation here. So first element is 0. I multiply R3 with 7. I multiply R3 with 7, R2 with 4, and then we make the subtraction here. So this element we get to be is equal to 0. Next 4 into 728. 4 into 728 minus 5 into 4 gives us 20. So the next element is 8. Next I transform R4. R4 tends to 7 times of R4 minus 3 times of R2. So again this element becomes 0. We make the transformation with R4 and R2. So the next element here we multiply the last element with 7 and this R2 element with 3. So this element becomes 0. The next element 2 into 7, 14 minus gives us minus 1. Next transformation, we could see the last row must be a 0 row. So we have to make the transformation. Until then, second row remains as it is, third row remains as it is. I am going to transform the fourth row here. R4 can be made the transformation only with the previous row, that is R3. So this is 8 times of R4 minus plus R3. So we get 0, 0 and 0. So the number of 0 rows is 1. The number of non-zero rows is 3. Therefore, we say the rank of A is equal to 3. The fourth question, A is equal to the matrix. Given A matrix, we make the elementary transformation here by taking R2 to 3 times of R2 minus 2 times of R1. The first row remains as it is. We are making the transformation with R2. So what is that we are doing? Multiply R2 with 3, multiply R1 with 2. And then we subtract both the rows. So we get 6 minus 6, the element becomes 0. Next 1, next element multiply with 3, 3 minus 10 gives us minus 7, 12 minus 4 gives us 8. Next similarly R3 tends to, I want to make this element to 0. So R3 tends to 3 times of R3 plus R1. So we are going to multiply the R3 with 3 and then add with R1. So the elements are 0. Next element will be minus 2. So 6 plus 8, 6 minus 8 gives me minus 2. Next 3 into 3, 9 plus 5. 9 plus 5 gives us 14. Next minus 2 into 3, minus 6 plus 2 gives us minus 4. Next transformation, our aim is to bring this A32 element to 0. So what is the transformation we are going to do here? This is R3 tends to R3 plus 2 times of R2. So I am going to, first row remains as it is, minus 8, 5, 2. Second row also remains as it is. We are going to make the transformation with R3, where R3 we are going to make the transformation with 2 times of R2. Multiply the second row with 2 and then add. So we get the last element to be 0. Next element, multiply becomes 0. Next R3, 14 minus 14 gives us 2 into 8 is 16. So this element is 12. The number of non-zero rows is equal to 3, and therefore we say the rank of matrix A is equal to 3. The number of non-zero rows is 3. The last echelon form, the last matrix is in row-echelon form, and therefore the rank of A is equal to 3. You can write the number of non-zero rows is equal to 3, and therefore rank is equal to 3.